So these are your molar mass of a compound notes. They're very short. Molecular weight and molar mass are the language things that we'll be using for these notes. So molecular weight is the sum of atomic weights of all atoms in the molecule. All right, so the example is sodium chloride has a molecular weight of 58.5 AMU. So just a reminder, AMU stands for atomic mass units. And this is composed of one single molecule of sodium chloride. So if you have those two atoms that are bound together to make the molecule sodium chloride, its molecular weight is 58.5 AMU. Molar mass is very similar, but it's just the molecular weight in grams. So the example again, sodium chloride, it has a molar mass of 58.5 grams, and that's made up of 1 mole, or 6.02 times 10 to the 23rd molecules, but it's easier just to think about it as 1 mole of sodium chloride. So a lot of times you'll see this written actually 58.5 grams per, so a little slash, mole, and you'll see that example here in a moment. So there are 3 simple steps to calculating molar mass. The first one is you find the atomic mass of each element in the molecule. Then you multiply the atomic mass by the number of atoms of that specific element in the molecule. And third, you add the product for each of those multiplications for each element together, and that gives you your molar mass. So an example would be for C6H6O6. So the first step is to find the mass of each element. So carbon has an atomic mass of 12.011 grams per mole. Hydrogen has an atomic mass of 1.008 grams per mole, and oxygen has an atomic mass of 15.999 grams per mole. And the place that you find these numbers is just on the periodic table. So if I look on the periodic table for carbon, remember the mass number is below it, and that's where I got 12.011. So that's the first step. The second step is to multiply the mass for each element times the number of atoms. So I can look up here and say, okay, for carbon, there are 6 atoms. So it'd be 12.011 times 6. For hydrogen, there are also 6. And then for oxygen, there are also 6. And then the third step is I add all of those together after I've done the multiplication. So it's important, if you're just going to type all of this into the calculator, you have to include these parentheses for order of operations purposes. Or you could do this multiplication and write your number. Do this multiplication, write your number. Do this multiplication, write your number, and then add those 3 numbers together. If I did that, I get 174.108 grams per mole, and that's my molar mass. So you do not have to write this slide, but here are just the molar mass and number of particles in 1 mole quantities of different substances. So the first thing you'll notice is that regardless of whatever the substance is, so if we're talking about caffeine, the molecule, or if we're just talking about carbon, the element, that the number of particles in 1 mole is always this number here, and we'll talk about that in a different topic. But that based on what the element is made up of, the molar mass actually changes, okay? So these are your atomic mass notes, and now you have practice problems in Google Classroom.